My name is Tomas Donik, and I'm sales director of Mega Company, producer of Electrodialysis. And I am here with Cesare Rivera, technical director of PHI, and we are in Bodegas Reconquista in sunny Spain. So, Cesar, can you tell us where we are right now? What is this room?
Okay, we are in Bodegas Reconquista facilities. This is the fermentation area, right, and the aging area. There is the reception of the grape, but inside of this room, we fermentate the grape juice into wine, right? Then aging the wine in this oak barrel, and then finally we bottle the wine, right? So this is a simple steps of wine production, okay?
Okay, great. Very nice facility. Okay, so today we are here and we will be talking about tartrate stabilization.
That's right.
So can you tell us what is tartrate stabilization and what it does?
Okay, tartrate stabilization is the method to remove or to prevent crystals that need tartrate, right, to deposit in the wine. So customer doesn't want to see that crystal in wine, so they want to be to see a clear wine. So we need to remove or stabilize the wine to remove that crystal.
Yeah, so we will be talking about electrodialysis later, right? But do we have any other method? Because electrodialysis is quite a machine, right? But I think originally or traditionally you had to do it some way. So what are the methods for tartrate stabilization?
Okay, I can explain about this because I have tried all of the kind of methods. First, we use cold stabilization, right? So we freeze the wine, the crystal sediments, and then we filter the wine, okay? We filter the wine in order to remove this crystal. This is a good technique to remove crystals, right? But you need a lot of energy consumption, right? Because you need to reach a low temperature, maybe from in this area, even in Spain is a hot weather, you know, so you need a lot of energy to reduce the temperature.
That's right. Temperature changes are, let's say, energy most demanding processes, heating, but mainly freezing and cooling. Plus you have sludge at the end, so you are losing a little bit of wine.
That's right. We have a sediment. We need to filter the wine, so we have a sludge, right? It's like water, and we lost a lot of wine, right, because of this filtration.
So do we have some other options today?
Yeah, there are more options. For example, ion exchange, right? It removes cations, right, like potassium, like calcium. If we remove it, there are less possibilities to generate that salt, that crystal, and precipitate, right? And ion exchange resins, it introduces hydrogen into wine. So it modifies, it lowers below the pH of the wine. So it modifies a lot the wine. So if we want to stabilize the wine with ion exchange resin, with cation resins, the wine wasn't good to taste because it is too acid. Other point is there are a lot of waste on ion exchange. Acid water that it is too difficult to manage. So this is a bad point.
That's correct. Plus, it's kind of additive method a little bit because you need to regenerate the resin.
It consumes a lot of organic mineral acid. It consumes a lot of, for example, sulfuric or chlorhydric acid, right?
So you need to get it in, and then you need to somehow get it out and treat it out. So you are producing a lot of wastewater or salty wastewater because volumetrically wise, probably it will not be so much as on TDS level, on a mass of the salts.
It's not a stabilized method. People say that cation exchanges is for stabilize the wine. I say no. It's only to acidity the wine. It helps other technology, but definitely is not an stabilization technology for me. Okay. Additives. Then there was a cool stabilization. Then appeared the chemicals. Right. We introduced the chemicals, the additives into the wine in order to prevent the crystallization. We don't remove the crystal. We only produce big molecules that it's too difficult to precipitate. But definitely this additive is in the wine and we drink it, so it is inside our body. Maybe it's safe, there is a lot of studies that are safe, but people doesn't know in even years that say that medicals it is not good for, definitely for health. Right?
And the last thing what you want is when you drink wine to think that you have absorbed also some chemicals.
Definitely.
With it. Right.
Now you need to declare these additives into the label of the wine. So you need to put it that this has, because it's not natural from the grape, it's an additive. So we need to put it into the label. For example, it's not allowed in organic production of wine, right? For example.
Also, there is one point which we discussed before, when you have the wine is changing over the time, right? So it may not be 100% stable over the time, or if you have a long shelf life of the wine, then precipitation at the end may occur anyway. So.
Definitely is other point of chemical stabilization. Maybe with a short time in the market wine, it works, but if the time in the market is too long, maybe it doesn't stable anymore and it precipitates. So it is a method, but you can't prevent for a long time stabilization with chemicals. That's other point, right?
And this is why we are here,
this
right?
Is why we are right.
This is why I'm here from electrodialysis producer. So the last thing, last method is to do it with electrodialysis. It's not exactly new method, but it's also not old. It's kind of in between, and definitely is one of the better methods. So maybe just to explain for the people looking at us, what is electrodialysis? Electrodialysis is electromembrane process, right? We are using DC electrical current, and by two types of the membranes, an ionic and cationic, we remove ions, salts, and some organic acids with tartrates from the wine. So we even don't do any filtration, we don't do anything, we do very small amount of salts that we remove from the wine with electrodialysis, right? So if you look on this technology, what benefits do you think it has comparing the others?
Okay, first it is a real stabilization because we remove the excidium of the salts, right? If we remove it, it can precipitate, right? It's quite similar of cool stabilization, right? But the main advantage versus cool stabilization is the energy consumption, right? We don't need to cool the wine. For example, the wine enters with 20 degrees and it out from the unit at 20 degrees. There is no modification of the temperature, right? So energy consumption is too low.
There is also another good thing when we are talking about electrodialysis and energy consumption, that if you have a lot of salt and you need to remove a lot of salts, then your energy consumption may be higher. But what we are doing with the wine, we are just moving the salts and the tartrates a little bit below the precipitation limits. You need to remove very little, right?
It's around, we have see that we need to remove from maybe 10% to 25% the maximum. Is enough to get a real stabilization of wine, right?
In the liquid, like wine, that doesn't have a lot of salts anyway. So power consumption at the end will be very little in this sense.
That's right.
It's also good to talk, when we are talking about the process, that comparing some of the other processes, this is continuous one-pass process, right? So you have tank on one side, the feed tank.
This is continuous technology.
The product on the other side. So you place it on site, plug in, and it will continuously remove all of the salts. So it's very easy for operation. Right?
Okay, that's definitely too easy because we don't need more tanks or modify the facilities or the wine cellar, right? Because, for example, you can see that this is a small winery. We don't have a space to introduce more tanks. So we only need one tank, a normal tank, feed tank, the unit, and then an outside tank, right?
Yeah.
So we only need 2 tanks. We don't need more other stuff, right?
Yeah. So when we are in the operation, so we said we need, of course, feed water for feed wine over here. Then you have some product and you need to connect it to it. You need some processed water. You need to have chemicals for chemical cleaning later on. I think this will be separate topic,
right.
but nothing more.
And not more.
These machines are fully automatic. So when we are talking about this machine, there is a local PLC when you can manage complete machines from the PLC. If you are a small winery, you can use this local PLC. If you are a big winery, you maybe have some control room and you can connect it through the internet to your main control room, right?
That's right.
So this is the process, but we started to talk about it. So what about, let's say, maintenance and cleaning?
For cleaning is in a normal cycle of production. When we reach the production set point, we touch the sip process and it is fully automatic.
Yeah.
Okay.
So this is what we are talking about, right? This is the HMI, and this is the dosing station or CIP station, cleaning in place station.
It needs an alkalic product, it's like sodium hydroxide, and an acid, an organic acid or mineral acid like nitric acid, right? But its consumption is too low, right? Maybe 3 liters per cycle of sips. We need to know this because, for example, people know that things that is like ion exchange resin that generates that needs a lot of chemical to regenerate. It's only for clean the membrane.
Yeah,
so
no
the chemical consumption is too low, right?
Yeah.
It's too low.
Okay. And it is fully automatic. So here are the dosing pumps, the recirculation pump, and you set up
just put it, sip, and he cleans by itself.
Yeah. Okay. So that's cleaning. But what about maintenance? So we have the only maintenance or regular maintenance, let's say this way, is done on electrodialysis modules and electrodialysis stacks, right? So what is it? Electrodes on both sides and interchanging membranes, anion, cation with the spacers. So what is happening inside is that basically wine is going in, traveling from point A to point B, and while it's traveling from the bottom to top, we are removing the salts and wine is becoming stable, right? So what can you send us something about the maintenance purpose or the replacement of membranes?
The maintenance is too easy, right? It's too easy because we can be done in our factory, right? Technical staff comes to our factory, open the stack, right? It's too easy. It inspectionates the membrane. If any of the membrane is damaged, we change that membrane and declose it again, and it is too easy.
Yeah,
and it is produced in our factory, so it's quick too.
Maybe one more question, because before we've been discussing, and this is what you said, that we need to remove only like from 10 to 25% of the salt. So how, because every wine is different, how I know that I need to remove 10 or 25 or whatever?
Okay, this is the first step, okay? The first step is we need to analyze the wine before work with the unit, right? We get a sample of the wine, for example, from the tank, we get a sample and we analyze the wine, right? This is a check stab, this is a quick contact method, right? This is based in Bulthon method, right? Where we read the conductivity of the wine, right? In this unit, we freeze the wine, right? And we see how the conductivity drops. We introduce potassium hydrogen tartrate, right? In order to accelerate the crystallization, and the precipitation of the salts, right? So we can see how the conductivity drops. When conductivity doesn't drop anymore, we can decide that the wine is stable, right? So, for example, we have this conductivity, and then we have this one, in maybe 1 hour, it doesn't move anymore, so we need to removing that percentage of salts. For example, at this method, we need to remove 20% or 23% of salts, right? So
when
we
it's already-
see it,
yeah.
we see it, we go to the unit and put it. The percentage of desalination starts and not anymore.
Yeah.
Right?
So you
Not
just
anymore.
put it in, start it, and it's starting to run.
Yeah.
And this is everything what you do with at the beginning of the
Beginning,
process.
the first we analyze, then
Yeah.
put it the desalination set point at
Yeah.
not anymore. Too easy to work.
Yeah. Good, great. Hey, it was great to talk to you.
Thank you very much. Thank you very much, Thomas.
Yeah. Okay.
Bye.
Bye.